Okay, we're going to be adding and subtracting rationals with unlike denominators. We've been doing rationals with like denominators for a while. Okay, so this is what the problems will look like. They'll be fractions, and they'll be rationals because they have their fractions. All right, that's what rationals are. They have fractions. And I want you to notice that their denominators are different.
Right.
But I want to take us back to when you were in elementary school and you learned how to add fractions that just with numbers, okay? So if I had 3 over 2 plus 6 over 5, or even let's do 6 over 12. Nah, 5 is good, okay? Okay. All right, we're going to find the common denominator, okay? So we ask ourselves, what number do both of those
10.
multiply into it? In this case, it's multiplying them together, right? Okay, so I picked 10, right? And then I say, 2 times what gives me 10?
5.
5, so multiply that by 5, right? So that's 15. Bring down my plus. 5 times what gives us 10?
2.
And that's 2. Since I multiplied that by 2, I multiply that by 2, and I'll get 12, okay? We have been doing this piece for a while without the adding. So they've worked your way up, so this isn't totally foreign, okay?
Right.
Then we just add the numerators,
And
which
that'll
is
be 27 over
27 over 10. And then if we can't reduce that, we're done. The way we'd know we reduce it, we'd try to find a factor that goes into both of them.
10. Right, but we can't.
But we can't, that's right. So we're going to now do the same thing here, but with letters. Okay? So we're going to do this one up here, and we have to ask ourselves, all right, so to be able to do this, we're going to find the least common multiple. We've done this before, okay? And the least common multiple, it sounds backwards, but we take everything. We take everything, the highest amount of thing that's in common. So we have a 2 on this side and no 2's over here. So which one's more? 1 2 or no 2's?
No, 1 2.
Yes, we take a 2. And we have a 3 on this side and none on this one, so we take a 3, right? And then we have an x squared and an x, which is the highest.
X squared.
Okay. And we have a y and no y. What's the highest?
Y.
Y, okay. I'm going to actually clean some of this up. I've got all these dots everywhere. And I'm going to turn this 2 and the 3 into a 6, okay? It's going to be better. And then we'll have, clean it up so it looks better. So we'll do the same thing on there. We're going to have a 6x squared y and a 6x squared y, all right? Bring down my plus. Then I ask myself,
so then you
okay?
just do 7 over 6x squared over 6.
Almost. We can't add just the 5 and the 2 because we changed the denominator here. So we have to figure out what we multiplied it by. So we ask ourselves, 2x squared multiplied by what gives me 6x squared y?
6y.
Careful. 2 times what gives you 6?
3y.
3. So I'm going to actually change colors. This is going to be, right in here, I'm going to make it teeny. We made a 3y here, okay? So since we did a 3y in the denominator, we have to do a 3y in the numerator. So this new thing will be a 15y. Does that make sense?
Mm-hmm.
Okay. So what do we multiply the 3xy to get the 6x squared y?
The 2x squared. 2x.
Just 2x, that's right. So I'm going to do it in a different color again. We're going to have 2x here and a 2x here. So then we multiply that together there, and that becomes 4x. You with me so far?
Okay, yeah.
Okay. We rewrite our denominator, 6x squared y. Add those together.
So 19xy.
Careful, careful. That's a temptation. I'm actually glad you brought that up because these are not like terms.
So we can't add.
Cannot add them. So it's just going to be 15y plus 4x. Looks big. We're done. Okay.
Okay.
Let's do
It's
another.
not as bad as I was anticipating.
Right. This time, last time we had things that were multiplied together. We just had those. They were multiplied. This time we're going to add something in there. We're going to add in some additions and subtractions, okay? So our common denominator, just a second, our common denominator, we have an x minus 1 on this side. Do we have an x minus 1 over here? Do we have an x minus 3 over here?
No.
No. So there's nothing in common, and so we have to take it all and just multiply it together. So we just have, I'm going to have to write this big, an x minus 1
And an x plus 3.
and an x plus 3. And so we have an x minus 1 and an x plus 3. Right. Then we say we have an x minus 1, and it multiplied by something to give us x minus 1, x plus 3. So what did I multiply this by to turn it into that?
The x minus 3.
Very good.
And we actually did this opposite, because it should be a plus 1 and a minus 3.
We did it backwards from over there.
Mhm.
Ah, thank you for fixing that. So I should put this needs to be, thank you. Very good. So I need this to be a plus 1, a minus 3, and a plus 1 and a minus 3. Very good. So I multiply the top. Since I multiplied this bottom here by an x minus 3, I have to multiply the top by an x minus 3. It's okay?
Right, yeah.
Multiplied by 1 is just x minus 3.
Okay.
Okay?
Okay.
Down here,
An x minus
it's
plus
an x,
1.
yeah, it's an x plus 1 because that's what we need to.
And so it'll actually be, okay, and so this
Yes.
will be,
Plus 1. Plus 1.
right, x, and then this is going to be 2, open
Mm-hmm.
parentheses, x.
Yes, and you could distribute that if you'd like. 2x plus 2 if you'd like.
Okay.
Okay, all right. So then my common denominator is x plus 1, x
And
minus 3, and then these.
the numerator will be, you're going to have to distribute the,
That's
so you're
good.
going to, this will become negative.
Yes, and then we have positive there. Very
Okay,
good.
and so then you're going to do x,
Because these will become
Um,
negative x, right?
right, negative
And
x.
these will become,
It'll become negative 5.
very good, minus. Nothing can reduce. I can't cancel. There's not a negative x minus 5 on the top or anything. So I am done.
Okay, this isn't
Okay.
really that bad. Box method.
It's going to be a little bit different. We're going to have to, yes, factor this one. So we're going to have to do the box method.
So x and x,
Uh-huh.
4 and 1, and then negative and negative.
Yes. Okay. So this is going to become x minus 4 and x minus 1. That's how I got it from here, right?
Right.
Okay, so let's erase this so we have room to do our other stuff. Okay. All right, over here we're going to do the box method again also. Good. We're going to have x and x.
And, no. And 5 and 4.
5
you're
and
gonna do
4.
Negative and negative.
Negative and negative. So this is going to be x minus 5, x minus 4, and then I'm going to erase this stuff so we have room to do our work. Okay. Okay, now, are there anything in common in both of these?
Yes, the x minus 4.
Okay, so when we're doing our common denominator, we only, since there's 1 in both of them, the highest amount of them is one of them. Okay? Is there an x minus 1 in the other one?
No,
so we have
we'll
to.
do x minus 1 and then x minus 5. too.
Yes. Okay. Woo! I don't know if I'm going to have. This is what I'm going to do. We're going to. You can do it this way also. You can write it twice, or I can put my plus here and put what this stuff on this side goes over here, and then this stuff from this side goes over here.
Okay.
All right, just so we can save space. We're getting out of it. All right. So, of these 3, there's something missing to equal this. Which one is it?
The x minus 4?
We have an x minus 4 right there.
Right. Okay, so I don't know.
What do we what did we multiply this by to equal this?
1.
We
Each
have
other.
we have 2 here and we have 3 down here. Which one is missing up here? I have an x minus 4, an x minus 1, and an x minus 4 and an x minus 1, but one of these is missing. The x minus 5 is missing up there.
Oh,
Do you
so we have
understand?
to multiply by the x minus 5.
Yes,
okay.
so we have to multiply by the x minus 5 here and the x minus 5 here. When I distribute that, that'll be 3x minus 15. Okay?
Right.
All right. So, over here, I have 2 of these, and I have 3 down here. What's missing?
The x minus 1.
The x minus 1.
So then you'll have...
So I'll have the x minus 1 here
and then you...
to make it all work out.
So it'll be x minus 1 still.
Yes, x minus 1. Okay? We're going to have to reduce, we're going to have to move this littler so we can fit it all. Okay. Like terms. Are there any like terms in this numerator?
You can do 4x minus 16, and then put your bottom.
And all this stuff, I used to have a professor in college, instead of rewriting it, he would just write the word stuff under here, stuff. But we won't.
Oh man.
Isn't that crazy? Okay, so we're
I
gonna
wish I could do that in my schoolwork stuff.
Yeah, I know.
Stuff.
X minus 1, X minus 4, and X minus 5. Such. Yes, okay, now, can we factor that?
Yes.
What can we take out of both of those?
2x minus 4.
We can take out just a 4 out of both of them, right?
Oh, yeah.
Okay, so we'll have an X minus 4 over X minus 1,
my word.
X minus 4, and X minus 5. Why did I take something out?
Because now you can cancel.
Yes, and so then it gets smaller, and I'll have a 4 on top.
And then x minus 1 and x minus 5.
All right, so the reason we did this problem was so that you could see that you need to reduce in the end, and we have to factor at the beginning too. So we factored at the end to reduce, and we factored at the beginning to find the common denominator. Okay. All right,
They're not really too hard. They're just not very fun.
They're longer. Yeah, they're longer. Okay. All right, so we have.